Hello everyone, my name is Aman El Abuhai. This is my master's project presentation. My topic is an evaluation of available hospital beds relative to the population distribution in Texas using adaptive bandwidth log relative risk. My advisor is Dr. Michael Teufelsdorf, and I would like to thank you, Dr. Michael. My motivation for this project is I have read articles about the accessibility of healthcare facilities in Texas from uh, the Houston Public Media and the Dallas Morning News. And according to these articles, Texas has ranked at the bottom uh, in public health access and affordability and application of GIS in identifying and examining the local disparities for public health access is vital. According to these articles in Texas Department of Health and Human Services prediction, statewide in Texas, there is a shortage of 3,375 primary care physicians, and this will uh, grow by 67% by 2030. So my objective is my research questions are how does accessibility to hospitals and their capacity in Texas vary across the state, and how does the demand for the hospital beds vary across Texas, and to identify area of over and under supply of hospital beds or relative risk, and which factor may explain any discrepancies in demand and supply. What is public health accessibility? It's the availability of good health services within reasonable reach of those who need them. Although the concept of accessibility is multidimensional, it can be defined in terms of affordability, geographical acceptability, availability, and spatial accessibility. The focus of this project is on spatial or geographical accessibility. And some of the measure of geographical accessibility are provider to population ratios, distance to nearest provider, average distance to a set of providers, and relative risk surface or kernel density. Uh, Kernel density point patterns. Um, a density is a function that defines the probability of observing an event, and an intensity is the average density of points or expected number of points per unit area. And small bandwidth causes granularity, and large bandwidth causes over-smoothing in kernel density point patterns. Here to compare fixed bandwidth versus adaptive kernel density, the human population dispersion is highly heterogeneous with natural as well as man-made features such as towns, rivers, and cities. And the fixed kernel density estimator will struggle to capture important details when we use a large amount of smoothing. And on the other hand, if we use less smoothing, uh, we can expect see spurious or bumps in the risk function or in the density function. So a more intuitive approach is therefore to implement a variable smoothing bandwidth, especially uh, with a state as heterogeneous as Texas. Using fixed bandwidth is difficult. So if we look at the population density of Texas, we can see from this map that the population density is highly heterogeneous, highly populated area around this DFW, Austin, San Antonio, Houston metropolitan area, and very sparsely populated in West Texas and um, southern Texas. So the important map layers for this project are Texas hospital locations with their number of beds and type of institutions, uh, general, army, or specialized type of hospitals. And the number of beds are used as weight. And the 15,799 census block groups with their population counts. Um, and the Texas Census County Polygon is used as a set of attribute information for subsequent investigation of potential determinants to explain the disparities in the hospital accessibility. So this is the map of 655 hospitals in Texas, and data preparation, selection of varied hospitals. So only those hospitals which doesn't serve a specific target population were included in the analysis. So this left 521 valid hospitals with around 64,000 beds. So cleaning the hospital shape, I removed the closed hospitals, removed hospitals which doesn't have bed attributes, and select only general hospitals because the army and veteran hospitals they uh, are used for special groups. They are not open for the general public. So this is the summary of hospitals and the definition of the target population. Since army personnel and veterans are frequently visiting specialized hospitals, they are removed from the population. So only civilian population is used as a weight for the block group, and the map is projected into UTM coordinates um, using zone 14 for Texas, which is suitable for Texas map, and the map is converted into raster grid to convert into PPP objectives or point pattern objectives with a raster mask of 5 kilometer by 5 kilometer resolution. And the hospital point is the block group coordinates are used as uh, coordinates to create the PPP objectives. To say more about weighted adaptive kernel density, weighted adaptive kernel estimation is a method attempt to optimize the value of bandwidth. Uh, so given there's an observed pattern of event locations, we can experiment different value of bandwidths instead of one uh, fixed bandwidth to explore the intensity using different degree of smoothing and to look variations at different scale. So it's important to adjust the value of uh, bandwidth locally at different points in R. So this is done using the SPAR package. So using this method, this is the hospital surface using adaptive bandwidth of 20 kilometer global bandwidth. As we can see from this map, even though the global bandwidth is supplied 20 kilometer, it varies from 10,000 to 100,000 meters or 100 kilometers. And due to traffic congestions, 10 kilometer drive time in urban area is equivalent to 30 kilometer drive time in rural areas. So we can say that this adaptive bandwidth is suitable for this heterogeneous uh, distribution of hospitals in Texas. So the average intensity is this one, really small, very small number, uh, and 521 hospitals. And the block group surface is done using the adaptive bandwidth with 15 kilometer global bandwidth. I've experimented with different global bandwidths, but the 50 kilometer is the most convenient one, which doesn't over smooth or with less smoothing. So even though the specified global bandwidth is 15 kilometer, it starts from 5 kilometers for the highly densely populated areas, the dark blue areas, yep, and it goes up to 80 kilometers. So for the Texas population distribution, which is highly heterogeneous, this adaptive bandwidth is suitable and it seems reasonable. When we come to the log relative risk surface, suppose we have two sets of bivariate observations, x1, x2 up to xn, and y1, y2 up to yn, uh, representing Cartesian coordinates of case and control locations. And we can have a function, risk function, which is case over control. That means r of z function equals f of z divided by g of z. So the interpretation is if it's greater than 1, then the case density is greater than the control, so that's the area is overserved. If it's less than 1, then that's the area is underserved. If it's 1, case density is equal to control density. So using this formula, I calculate the bivariate risk and calculate the tolerance, which is an asymptotic p-value method. So from the risk map looks like this. We can see uh, the the metropolitan areas are have high access or highly have higher access, but the surrounding counties are underserved because they are using these facilities from the cities. And some of the most affected areas or the underserved area include in El Paso, southern Texas, and here above around here, this area. And also this contour shows it indicates a significant elevated risk, or it's calculated based on asymptotic theory describing the extremity of risk. So the smallness corresponds to statistically significant elevated risk. So the for this area the number is small numbers, which shows high risk, and for this area the p-value is 0.9 0.95. So when you come to hospital uh, accessibility by county, then this is converted into uh, tessellation by the county level, because most of the policies are done at county level. This histogram shows the density of the supply and the discrepancy map between hospital beds, supply and demand surfaces shows that all these the metropolitan counties are underserved, and the areas with red color are overserved with over 0.343, and above that, some of the most underserved areas include El Paso here, southern Texas, uh, counties with exception of these counties, and the sparsely populated counties of the central part of Texas and Edwards Plateau around here are found to high over access or have higher access, and this around these counties also have uh, over access to hospitals, and identification of the relevant exploratory variables. So the political orientation of a county may indicate potential leverage to obtain funding for local hospitals as well as general, uh, and a high proportion of uninsured population stresses the healthcare supply. And counties with an older population will demand more healthcare as well as a high birth. If there is a high birth rate in a county, the demand for more healthcare is high. And distance from Mexico border reflects some cultural shift, and also some education, income, and poverty will affect the access. So using the scatter plot, try to explore the relationship, the correlation between the access and, for example, Republican voters have higher access, whereas the Democratic counties or Democratic voters have lower access. Insurance doesn't have any effect, and median age as well, it doesn't have any effect. The birth rate have high access, but I mean have high demand, but the access is low. So, and distance to Mexico doesn't seem have any impact, and as well as the black population doesn't have any impact, but the Hispanic origin have less access, as well as college degree doesn't have any impact, and poverty also have some negative impact on the access. So when we see the hospital access by urbanization, we can see that from this box plot, light urban areas have uh, high median access, as well as rural and followed by urban, and the metropolitan areas have lower median access. When we see the access by regions, we can see that the low rolling plains and uh, lower valley have higher access, but central and south Texas have lower access, as well as uh, some East Texas in some counties in East Texas, and upper coast is have some higher access, and this another factor is religious adhesion. So the more the religious affiliation group there is, the demand, I mean the access increases. So maybe this is due to the community help each other to build uh, healthcare access. I mean healthcare facilities. So religion and politics have higher implications for this case. And heterodicity regression model shows that uh, The variability of the pixel values within a county expresses the uncertainty in the log relative risk uh, estimate of that county. So this variability will manifest itself as a heterodicity in the regression model. As we can see from the model diagnostics, the nonlinearity check, the more Republican there is higher access, and as the to the black population group increases, also the access increases, and here uh, the the distance to Mexico, as the distance decreases, also the access uh, decreases. And this is the religious group affiliation. So the group involves more in religious, so the access increases. In here, the residual diagnostics shows that there is no significant outliers, except these few outliers. And this map shows the residual normality investigation. And so the exogenous variables are properly specified, and there is no significance outliers presented, and that the residuals are normally distributed. And spatial residual diagnostics, we can see from the residual pattern of the supply and demand model that this residual has a clear pattern, and it's not random. That means there is a spatial autocorrelation. And we can also see from the Moran's eye plot that there is that the p-value is very small. That means there is a positive spatial autocorrelation with few outliers. And from the coloregram of supply and demand, we can see that it's highly invariable. So there is you can say that there is uh, a spatial autocorrelation. So the correlogram indicates that the underlying data generating mechanism is more complex than what we'd expect for simultaneous autogression models. In conclusion, the adaptive kernel estimation is highly recommended and preferable for the heterogeneous uh, population as Texas, like the distribution of population and hospitals in Texas. Counties which are surrounding to the metroplex areas are underserved, including those counties. And out of 256 counties, 66 counties were identified as oversupplied for hospital accessibility, and 46 of these counties are in the central and high plains region of Texas. This is partly due to the lower population density of the area, and those areas are called the Bible Belt. That means they have high religious affiliation groups. And the sparsely populated rural counties, some of the counties in the Texas are found oversupplied. And the total population density, Hispanic origin, demographic voters, and poverty have negative impact on the access to hospitals. Republican voters and Republican counties have higher supply. This is due to because Texas is a Republican majority state, and religious affiliated groups have higher access than the religious groups. So overall, this is uh, what I have, and These are the reference materials. And thank you very much. If you have question, you are welcome.